So here's a new function block because we need static memory. So there's something, we just call it enter exit location. You have a location where you are registering entries and exits, and you have to try to keep track of how many is in this location. Yeah. So there's a program where, and there's a function block that we have to make. Enter exit location, and an instant data block that we are calling here, and we have to call the program main again. It's one way or another. So make a program, a new function block. So we get to know function block. We get to know a function because we're going to call it in a function, but we're not going to use a function as that. An instance data block, organization block, edge testing. And you could check the compendium, just search for edge test and see how you do that. Retain parameters. We have got some parameters that they have to be retained. Validation of internal variables, status and error outputs, and validation of inputs. So the function block should input x1, that's entry, and x2 is exit. And these, they have to be edge tested. Enable input. If false, then the input x1 is disabled, and you should probably disable your entry mechanism of some sort too, so people can get in. So internal register on a positive edge, count up because there's someone new in the count internal here, so static integer. Yeah, and the positive edge should come down. One entry, someone has left. And then we need to initialize because maybe we say we have got 5 people already in here that we're not going to count. These are the lords and the ladies. They're already here and they don't pay. So we have to initialize our, let's say, our location with those 5 or whoever is here. Yeah, and we use that with an in-out parameter. We get to know also an in-out parameter. That's something we can read and write to. Parameter PHR, the capacity of the location, we use an integer, which the max is 32,657. Yeah, something, 32,000 something. Yeah. Yeah. Yeah, this internal register, the SE count can't be higher than this, and the input, the initial value, of course, you have to validate these and make sure that this one is not greater than this one, and the internal should stop counting, or you could continue counting, but then you have the overcapacity. Digital output, BH indicating location as full, and an output IF indicates that more people are entering location than the location capacity. Code heading, functionality, exception, processing inputs and outputs. This in code header. You should try to look in the compendium too for that. Test the function, call it in a FC without any arguments. This is our program element, and so on. So this is the interface. These are the inputs and outputs with some comments. These are edge, active on edge, and this one is on level. Output, and talked initialize. P, these with P, they are parameters, initial value, high range. They have to be retained, so you keep the value even if you lose power to your PLC. Here's the count internal, and you don't need to keep this retained because if this system is failing, maybe they have all left, so we can just start at 0, but then we could use the XI here to say, okay, how many are in here? 2 after my failure. I was 20. Okay, we say, then we start at 20 and let more people in. And here are these static Boolean for the edge testing. So look in the compendium for the edge testing, and here are the validated parameters. And then we have a minimum capacity in a location, which use a constant integer. We say that's 0. But we could say the minimum capacity was 1 because there's always one person in the checking entry and exit or whatever. But here it is 0. Yes. Program tips, there's no pseudocode or something like that, but here are the internals. On edges, we should do some counting. This count value should be output here. and then we have to do some comparison here for the BH, and then we have, if there is an entry and we are full, maybe we should set a failed output. We don't have a reset here, so the failed, maybe we could maybe keep the overfilled output until the counting value is below the maximum value. And this enable preset value is an in-out. So we read it. Okay, there was an initialize, do the initialization, and delete the input. So if you want a new initialization, you have to set this to true once more. That could be, for instance, from a panel or something like that. Okay, so these are the inputs, these are the outputs, and yeah, we have this internal SI count that we show that we're basically working on. So cinema, whatever. Here we have the enter exit location. Here we have the entry, because you're counting here, the exit here. So that's X1 and X2, and enable is a key switch. Should probably go to the input arrangement too and block this one, like here. But that doesn't have to go through the PLC, that can be directly, so this function block doesn't need to know that. Output is a red light when it's full, maybe on the outside, and a green light when it's not locked and it's possible to enter here. We don't count for that, but we could have had another output or something that indicated with a green light that entry it's enabled. And then we could have a display or something with attendance, how many people are in here. Yeah, this in a modern system, of course, this would be a TV screen or something like that. Yes, so that was the context, and that was about it for this one. So you have to program something like this, edge testing and counting and so on. Yeah, okay, so this was another function. It's a little more complex, entry, exit location, maybe a cinema or something like that. That just keeps track of how many people are in this area. Yeah, so it's just an example. And the main here is binary edge testing on 2 inputs, and then validation of inputs and so on. Yeah, so that's one.